Okay, so welcome to another tutorial, Computer Science 2A. We're going to have a look at something that is present in most IDEs, but it's something that you might not have used very effectively. So when you're looking at writing a program, and I've done this as well while I'm busy showing you how to do things, when you want to try and test certain data, what do you do? What's your thought process behind when you want to test if something works? So I'm asking you now, what do you do when you want to check if your program works correctly? You write some code, it compiles, yay, okay, now what? How do you know that it's running correctly? It compiles, your syntax is correct. How do I know that it's running correctly? How do I know it's getting the right input? How do I know it's getting the right output? How do you check? Usually it goes something like this. So let's say that I want to check that this list here has the correct information. So what do? Print out something. Either I print out the contents of the list, print out how long it is, print out exoplanet data, check its correct type, check if it's got the right parameters. You print out everything. And that's how you would check to see if your program is correct. But writing those extra statements in introduces more problems. What if the thing you write introduces an error? Then you run into a lot of more problems. So there is another way you can look at your code and check it as it's busy running. Because those print statements runs through your whole program. You can't stop it and double check things. It prints out everything as the code runs. But there is a way that you can debug the program. That's what programmers do. We take coffee, we turn it into code, and then we take more coffee, and then we take the bugs out of the code. We need to debug, take away any problems inside of the code itself. So with this, in your IDE, so most IDEs have this. Something like Notepad++ is a text editor, so it won't have this functionality. But if you look at your IDE, you usually have some way to run, and that's the way you've done it always. You run your program. So if you set up this as your main, you go run, and that's the thing you run, and then it will execute and do whatever it needs to do. But right next to that is a picture of a bug. And what you want to do, you want to squash bugs. You want to take them away, take them out of the system. So you squash that bug by clicking on it. Then something else will happen. First, if it's the first time you're doing that, it's not going to do anything. And that's because you haven't told your program to stop at a certain line of code and wait for you to continue. So the first thing we need to do is enable something called breakpoints. So breakpoints are a way to stop your program while it's busy running, stop it at a line of code, and you can check the data in your program at that point. So let's just see if this works correctly. I just want to double check that everything is correct here. Just give me a second. Okay, so everything there is fine. And once I put a breakpoint in, at least in Eclipse, it will ask you a question. And that question is, you're currently in edit mode. That's how you write your programs. You're in Java edit mode. It's asking, do you want to change the perspective now to debug mode? Because we're going to try and debug our program. So usually, if you want to debug, you can say, yes, you want to switch. If you forget to do that, there is a way to go back to it. But once you say yes, your layout is going to change. You'll see the code still in the middle there. But then you'll see some extra things. First, you'll see on the left-hand side, you'll see the current running application, the current running thread in the application, and it will provide you with some information there. So you can see there, we are currently running the main thread, and in the main thread, we're running bin.main on line 12. That's where we currently are. Here you have your code. We'll get back to that in just a moment. And then on the right-hand side, you can see something called variables, breakpoints, and expressions. Now, all of these are used to analyze your running code. For example, you'll see that this line of code stopped right here, before this line of code actually runs. So at this point in time, what is available to my program? Before line 12 runs, what is available to my program? What local variables are there before line 12 runs? No local variables. There's nothing. What data do I have access to? I have access to arguments. But arguments is currently empty. And you can see there, I hovered over the variable arguments, and it tells me it's a string array of length 0. So it's telling me I have 0 arguments. How can we check? How can we make sure this is actually giving me the correct data? So when you're in debug mode, there's a couple of other buttons that become available here. We'll talk about those in just a moment. Let's stop. Let's stop debugging. Let's change the code a little bit. So we're going to change our configuration for our bin main. We're going to change the arguments to our program. So we've used this to change the virtual machine arguments to add JavaFX here. We can also add program arguments, just like you did in C++ with computer science 1B, when you added to, you had to do something like the number of rows and columns, the number of things you had to put into the 2D grid that you're busy working with. So you can just put things in here. And we can then click debug. It will take a few seconds for it to get to the right place again. And you can check the arguments again. And what you can notice is it tells us what that array contents are. It says this array is an array of string and has 4 elements inside of it. It gives us an ID. That ID is used in other parts of debugging, but it tells me what each element in my array is. It tells me exactly what's there. So I can check and say, okay, if I need to use arguments for something, I can double check. First argument should be this, second argument should be this, third argument should be this. You can check those values. Now what we want to do is we want to run the code line by line. We don't want to run the whole program. That's what we do normally. We want to run the code line by line. So there's a resume button here that will go until the next breakpoint. So if we put a breakpoint down here and we click that button, it will run until that breakpoint. Or we can do a step into or step over. So the E shortcuts for that, you can see there's F8 for resume, Control F2 for terminate, F5 for step into, and F6 for step over. Step into will go into every function that is called at that point in time. So if I do now, I say I want to step into the code, I can check what happens in the constructor for a file. I am passing to this file constructor here 2 parameters of type string, and we can see what happens with that when I click step into. So if I click step into, it now takes me to the constructor that is actually being used. And I know it's the constructor being used because I can see there is the parent string and the child string, and there is the actual data for it. You can see there the parent string, so the first parameter there is data. The second one is the child string there is prim.dat. And if I really wanted to, I could go and change that here. And that's while the program is running. I can change and test this while the program is running. So I can change those values and I can test certain conditions. Now, obviously, I don't want to use that because that will result in my code having an error later. So I'll leave it as the default. But let's say, okay, I don't really want to go through the constructors and the other methods being called here because that's not part of my code. It's not my code. I don't really want to debug something that's not my code. So then you can call step return, which will go back to the previous location. Where does it go back to? It will go back to line 12. So you can see the left-hand side here, we have a sort of stack-like call structure. This is a call stack. What functions are being called one on top of the other, and this will go then back to line 12 after the constructor has been executed. So now constructor has executed, and what should have happened is that this variable here, after it gets assigned, so we just did the constructor part, now we're going to go to the variable assignment. I'm going to say step over, so that I step over that line, go to the next line, because I don't want to do anything with the assignment. But there you can see our bin file now has some data inside of it. It now is initialized. It gets the value that the constructor provided, and I can see some information here. It doesn't show me everything, but it shows me, if I go to the file class again, let's actually go to the outline, which will be in the Java perspective. And what I want to see here is you can see there is some private variables here, so private instance variables. And this is how you can change between the views. So if you want to go back to normal edit mode, you click back on Java. If you want to go to debug mode, debug perspective, you click back on debug there. It also highlights which line I'm currently on. So there you can see that line is highlighted. So I can click somewhere else, but that line is currently where I am. But I can see some private variables here that can show me some information about the contents of my class. So you can see there's the path, data, double slash, because remember this is a backslash, so backslash has to be escaped with Java strings. And it tells me what is the prefix length, the file path, and the status. So there's no status or anything you have to worry about. Now, if I was going to do the file object, file handler here, we could see some extra information. But here we're now going to work with the array list. I'm not going to go through the constructor, but maybe I want to have a breakpoint right there. Now here we can continue running the code. So I'm going to step over that line for the constructor. Now I'm at the place where we're going to add an element. But I can see that my list currently is empty. So here is the string representation. If I call toString, that is a string representation of my list. And you can see it is empty. There's nothing inside of it. Now, because I don't really have more code, we can't really step over this and check that we have the thing added correctly. We can step into, we can see the add method again, what happens there. We can say return. And what we should see is that code hasn't finished executing, hasn't gone to the next line yet. We just executed the method. This method does return something. It's going to get discarded because we haven't assigned that value. But we can see now that our list does have something inside of it. So we can see that we have something inside of our list, and it's something that we expected. There might be a situation where you don't expect a null in your list. How did it get there? You can run the debugger and check that that specific section of code ran. Oh, wait, at this point in time, it added a null because there was something that went wrong. You can check those things and verify that your code is running correctly. So let's stop this one. Let's go and try a different main. So this is our GUI application that we were looking at for education file system of our education system that we were developing. So I'm going to go back to Java perspective because that obviously gives me more room to see things. And maybe what I want to do is I want to have a breakpoint maybe here. So I don't need to run all the code right from the beginning, step through every single thing. I tell the code where I want to stop. All the things that happened before that, they can continue as normal. But when I get to a specific point, that's when I want to debug my code. So I obviously have to choose the correct main there. So then what will happen is it should go into debug perspective. And because of what we did, where the thing is, our code is executing normally. Nothing's changed here. Because I haven't hit the breakpoint yet, my code is just running. You can see that it's calling the redraw, where we move this mouse and the box moves around. And you can see there's more than one thread here. Because when you're working with JavaFX, there's some things that are running the GUI interface, there's some things listening to different events, some things that are going to create events. So there's different threads being run here. Now, we said we want to have a breakpoint when we actually start interacting with choosing a file. So that's after we've chosen the file, and we try and call read degree file from file. That's what the method we were looking at. So obviously I have to have an open. I have to choose a degree file. And once I click that, what you'll see is that it stops. It's no longer redrawing. Why is it no longer redrawing? It's actually waiting at that line of code. And you can see there's my local variables. Again, in the panel on the side for variables, you can see this instance, what is the current instance, what is the event, because we inside the handle action event. So that's the event there. We can see the chosen file. We can see something called C file as well. C file is a string. And we can see the degree that gets created out of that point. So we can check all this different information. If everything looks fine, I can go and check more things here. So there for the degree, we can see the degree code, degree name. There's an array list of students. I can check that array list, and it will show me all the elements of that. And I can click on them, and I can actually see the contents of that inside of there. Same thing goes for the modules. I can go through individual modules. Now, if you remember back to when we were changing the code, we changed students to an array list. We left modules as a normal array. We didn't change that code yet. And you can see there's a null inside of that array. So now you can see that you need to have a null check here if you're iterating over this array, because there is a null in there. But if I look at my students array, the way it handles things, there should never be any nulls in here. So obviously this takes a while to actually do all of these things. It's running a bit of extra code to make things run. So when you're using a debugger, some of the code will take up more memory. It will take longer to execute certain things, but it does give you all this extra information. So that's if I choose a correct file, all of those things happen. If I want to continue with my program as usual, I'll just click resume. And then you can see it goes back to the redraw loop where I am now redrawing stuff, and it displays something here inside the text area, because that's what we actually did. Now let's go and choose a file that is not correct. And I click open. So what's going to happen is going to go to that same piece in the code again, and we're going to have a problem. So you see it's stuck again. And here it highlights all the variables that have changed. So all the things in yellow are all the things that have changed since the last time you called the debugger at this location. So you can see the action event is a new event because it's a different time. The chosen file is different because we chose a different file. So you can see there it's choosing in the data folder CSC02A2. That's the file we chose. And that string that we display stuff, that's also changed, but we can see there, degree is null. What happened there? Why is degree null? So, okay, maybe at this point in time, it's too late to check why that's null. Let's actually put a breakpoint here and try again. So now I'm turning off one breakpoint. You can see you double click in the line here, just next to the line numbers, and that will enable or disable a breakpoint. You can also check all your breakpoints in your programs here. You can also enable and disable from here. So here, for example, I can turn off a breakpoint. So it's still there, it's just disabled. So let's say I want to go on to line 73, because that's when I call my read degree from file. So I'm going to let this run again so I can go back to my user interface. And what should happen is not crash, but let's see what's happening. Continue. Okay, so it just got stuck on another breakpoint, I think. So there again, we're going to choose the wrong file again. But what's going to happen now? It's going to go to the location. Just before I call this read degree from file. So we want to go check what that function actually does. So we're going to go step into, and that will take me to this method. And this method, you can see there we have a file handle, and it tells me what the file handle is. It's obviously that file. Then we can check, maybe you want to have a breakpoint somewhere else, or we can run through line by line. So I'm just going to use step over because we don't want to check the implementation of exists, all of that. So we can step over. So there it's going to declare a scanner as null. And then we're going to start initializing my scanner. So you can see there the scanner got initialized. That's why it's yellow there on the side. Then it's going to read a line of input. And I can see there's a line of input. And we can already see there's a problem. This line of input is supposed to be a header line for a degree. So this file obviously doesn't have the right contents, but we can verify that by carrying on with the code here. We have our matcher that gets created from our pattern that is declared somewhere earlier, using that header line as a parameter. And then we get to not matches. And if we check continue with our execution, we can see we do land up in the section that says the header does not match, and therefore it's returning degree. And we can confirm that degree is currently null because we haven't initialized it, because we don't have the necessary tools to initialize this degree instance. So currently, degree is null, and that's the reason why we get a null back over here. Degree is going to be initialized to null, and that's why we can't do anything with it. And if we run the next line of code, it does print out null in the console. So this is a different way that you can analyze your code and check and verify things are correct. Sometimes you might think, but I chose the right file. Why is this still returning null? You can verify. You can check the chosen file. You can maybe modify it. As it's busy running, oh, wait, I chose the wrong file. So let's do that. See if that works. So obviously I have to run this step again. So it's going to run through a few more things, get stuck, we'll run through again. Because there's multiple threads, that's why I have to click multiple times there. So let's go and choose the file. Let's choose the wrong one and see if we can modify it to be the right one. I'm guessing we can't because it's a file handle and not a string. Okay, so I manually changed it from a 2 to a 1. Not sure if this is going to work. I'm going to try anyway. And if I did see, it did look like it ran correctly. So even though this thing says it chose 2, we manually changed it to 1, and it worked because there you can see information about the module, which only gets displayed if the file is correct. Obviously, this redraw doesn't help because that's going to push our text away. So let's just go and turn off that. Let's just go back to edit mode. Try that again. So we're purposely going to choose the wrong file. So 02 is the wrong file. It will get stuck at the breakpoint. So it will take a few seconds to initialize everything that the debugger needs. Okay, so I'm gonna check this thing as on, so every time it will switch to debugger mode perspective if I'm in edit mode or Java mode. Okay, so it's stuck there at that point in time, and we can see that the file currently points to 02. You can see there it points to 02. So I'm manually going to change this to point to 01. So now it's pointing to 01. However, this string is already created. I could have done it a bit earlier before the string was processed, but just to show you that the original thing was 02, but my thing I changed now to 01. And then if I continue running, we can see there's the output for all the things that process. So this is the string that gets created with the wrong value or the old value. I changed it manually, and therefore we get a string, a degree that actually works, and we get degree information that actually gets printed out. So you can change things on the fly as you're busy debugging your program to fix something. Maybe you type something wrong when you ask for information. You want to just go fix it so you know that error was handled some way. Or maybe you want to force an error to happen. You can do that as well. So this is just the start of trying to use a debugger. There are other things. So the windows here on the right, there's a views. There's a view for the variables. So that will be the variables in the current scope. So whichever scope you're current in, it will show that information there. Obviously, we're not debugging right now. We finished, gone past the debugger. That's why there's nothing here. Then there's breakpoints. So that will indicate where there is breakpoints in your code. You can turn them off and on as need be. And the last thing here is a view on expressions. So you can type out a specific expression, check the answer here. So it could be something along the lines of checking if a file exists without actually writing the code for that inside the program. You could check whether one variable is equal to another variable by adding an expression and then saying what variables you are looking at. So this is only working while the debugger is actually working, but that's something that you can do as well. And this is just the starting of it. This is just the basics. There's obviously a lot more you can do with this. That's how you can check for problems in your code. This is how you can check for things that, even though your code, your syntax is correct, your program doesn't run properly. You can check why using something like this. Nothing's stopping you from just C out, or system out all the time. You can still do that, but that's a slow way of doing things because you have to run your program all the way to that point just to check that information. Whereas you can stop the program at any point in time using a debugger. Okay, so that was the first thing I wanted to show you. The second thing, probably not going to show you in depth. So that was trying to analyze problems in the code while it's busy running. The next thing, which is going to be important, is something called unit testing. Unit testing. So if you have to type it out, so unit testing. So what is unit testing? When you're writing code, especially a single class, you're not going to know every single parameter that will get passed to every single function in that class. You're not going to know every single thing. If it's a string, you can't predict what a user, whether that be another programmer or an end user, will type that will go into your specific functions. You don't know if it's a number, what number that person will choose to go into your functions. So what unit testing is about is testing to see edge cases. If a user enters a number that is greater than 10,000 and you're only expecting numbers less than that 10,000, what will your system do? If a user enters a negative number when you're expecting a positive number, what will happen? What will the code do? So when you're writing code, you write code to solve the problem. You don't write code to check if they're going to enter a negative number or check if they're going to enter a number that's too big. That's what you do afterwards. And you usually do it through something called unit testing. You test all the functionality piece by piece of a single class. Then after you tested class A, class B, class C, you test them working together. And if you do all of those tests and everything works out correctly, that means your program should, because it's never 100%, your program should, once it gets released, work correctly outside when it goes to an end user. So every programming language has their own way of doing testing. Unit testing is something known as the bottom up, because starting at the bottom, you're starting at the lower level, you're starting at the classes and then you're building up. There's other testing that comes into play as well when you do integration testing, when you're integrating one component, which is a couple of hundred classes, and another component, which is another couple of hundred classes, and you're trying to put them together. You need to test the functionality of two things talking together, whether it's in the same company or different company, you need to test those as well. And then you get something called end-to-end testing, testing a whole sequence of things that an end user does to make sure the system works correctly as well. Now, those things do get very complicated very quickly. That's why I just want to talk to you a little bit about unit testing. So unit testing, most languages support unit testing. If you want to add unit testing to anything in Java, you have to add it to your build path. And you can see there is something called JUnit. And JUnit is Java's unit testing framework. So it's a testing framework. It's a whole set of libraries that you need to use to make sure that this works correctly. Now, this is most likely not going to work 100%. And the reason for that is because you need to download stuff off the internet, and not sure if it will download perfectly fine. Looks like it got added correctly. Okay, so it looks like it got added correctly. And what you usually do is you want to go and create a new test case because you want to test a specific class. So I'm not going to go through the whole process of how test cases work, because that can be a whole discussion on its own. So here you have to give a name for your test case. What are you going to test? So you might say, okay, I'm going to test the student class, and you're going to test all the things that are going to happen there. There are things like if your class you're testing needs some setup. It needs to have files that are loaded. It needs to have a class that's initialized. You can do all of those things. So before it's set up, before each of the things are set up, afterwards, if there's resources that need to get freed, there's a whole bunch of things that can happen there. So it's a very involved process to try and get this thing working correctly. So you'll see that there is, actually I wanted to put this into the correct place. So usually tests go into their own sub-package called test. So that's where they should go. And you can see there, this is going to be a unit test that says, I'm going to test a specific thing. Now here, I didn't say which classes I'm testing. I didn't load them up because that's going to take too much time. But you can see there's a thing that says fail. So if a test fails, means something was not handled correctly. You might check that, okay, I set the student number to 1, and I test whether that student number is 1. If it's 1, you can say it passed. Then you can write something like pass or success. I think it's success. I can't remember what the exact method is here because each different version of JUnit, this is 5, I think I've only worked with 3. So each different version has its own things, but one of the things is saying fail, whether or not it fails or passes. So if something doesn't pass, you can say it fails. And there is a way to run unit tests that's a bit different. You can see here, instead of saying run as Java application, it says run as unit test. And what you'll get is a little window that will show you how many things were run, how many tests were run, how many errors there were, and how many failures there were. Now, obviously, this one here is resulting in a failure because we specified this is going to fail. If you write more tests, and then you run it again, then obviously you'll see the results of each of those tests. You also get information about how long the tests took. So the first one will take longer because that's the thing that gets set up first. Usually you have a dummy test at the start so that you can get the right information when you're busy running. But there you can see there's multiple tests you can do. So you can write code that will check. Besides running through the debugger and checking things through there, that's a manual way. This is a more automatic way of testing your code. So when you go into industry, you are expected to know these things. Or at least they expect you to know about it. But when you start working on your day-to-day job, you'll be doing a lot of this. When you're doing maintenance, which will probably be the first job you get as a software developer, unless you freelance, you're working for yourself, you're most likely going to be told to look at code first for at least 6 months before you write any new code. You're told to fix something first before you write any new code. And in order to understand how code works, you're going to run that code, you're going to check what happens, you're going to see how information flows through, and that's through either checking how the unit tests work or working with a debugger while the senior developer is watching you actually go through your business. So hopefully this has been insightful for you. End of the session is almost upon us, so I'm going to leave it there. As I mentioned at the start, this is just the tip of the iceberg. This is just the starting point. It's up to you to go out and actually learn more about how to do this. So you'll see, if you go speak to honors students, I'm not going to say that every second year will know an honors student. Your assistants are honors students, most of them. If you go speak to them, at least the ones who are working, they're studying part-time and working, the amount of times I've got told, I wish you spent more time on this, every year I get about 10, 12 people saying that. And that's the ones who come and actually tell me, not the ones who just ignore. So this is very important if you want to become a software developer. If you want to become a manager, maybe you're not going to look at code all day. Maybe it's not so important. But at least you know what your coders are doing when they're doing this. So it's important to know what those people are actually doing. All right, so I'm going to end it there. If you have a question, I'll answer the question afterwards. Next week is recess. Those of you who are at risk, please check E for the details of the intensive revision. It's only going to be one day. It's going to be 2 3-hour sessions with a break in between. Those of you who are not at risk, I would suggest you just keep on programming. You don't have to do programming just for the stuff we do in class. You can do programming on your own. Try and do something that interests you, just so you can keep your programming skills up to date, because 1 week after you come back, week 9, you write your prac test. Okay, so if you have any questions, I'll be at the front. Otherwise, I will see you after recess. Okay, so on the topic of the practical semester test, are you allowed to use handwritten notes? If you write the notes in the session, no problem. You can't bring in notes.